This is solving quadratics by completing the square. So we want to be able to answer what exactly does it mean to complete the square. So first let's review what does it mean to solve a quadratic equation. And remember that's looking for the x-intercepts or the roots or the solutions or the zeros, right? So that's solving a quadratic equation, is to find the x's. Now what two methods do we already know in order to solve a quadratic equation? We've graphed it, right? We graph from the vertex, use the pattern, find the roots that way. Or we've learned to factor it. Factor, then set each term equal to 0 and solve for x. So those are the two ways that we can solve a quadratic. So the third way that we're going to learn today is by completing the square. So here are the steps to completing the square. They'll make more sense when we do them together, but you can write them down if you want to. Move c to the other side, create a perfect square trinomial. This perfect square trinomial, remember a perfect square would be something where your binomials are the same. Okay, so a perfect square trinomial is when you've FOILed it out. That's a 25. So this would be an example of a perfect square trinomial. So that's what we're going to be creating. You know, this where they've got the same number. So they multiply to 25 and they add to 10, the exact same number. Then we're going to add the number to both sides. We'll factor it and we'll solve for x. So let's do this example together. Okay, so we've got a quadratic. It's equal to 0. We want to solve it. Now we could graph it. We could factor it. Okay, and this one might be easy to factor, but we're going to use this example to complete the square, so that way it's simpler, and you know what your answer should be. So the first thing you want to do is if you have an a, you want to divide everything out and get rid of that a. But in this case, a is 1. Sorry, if you have an a greater than 1, you want to divide it. But since our a is 1, then we're good. Okay, so our first step is to move c to the other side. So we're going to add 20 to both sides. So we've got x squared plus 8x, and then we're going to leave a blank or a box, whichever you like, is equal to 20, because we moved it over there, plus another box. So we're going to have to add something to both sides. So we moved the c over. Now we want to create a perfect square trinomial. So what number should we put in this box so that it's a perfect square trinomial? And in this case, and if you couldn't figure that out, there is a formula for it, and that's b divided by 2 and then squared. That's what goes in that box. Okay, so don't forget that. You'll have to memorize that. So in this case, b, our b, which is 8, we divide it by 2, that's 4, and square it, that's 16. And you need to put it in both boxes. So this is a perfect square trinomial because if we factored it, it'd be x plus 4 times x plus 4. 4 times 4 is 16, 4 times 4 is 16, and 4 plus 4 is 8. So this is a perfect square trinomial we just created. And whatever you put on one side, you've got to put to the other. So first step, move c to the other side. Second, create a perfect square trinomial. Third, we wanted to add, you need to put them on both sides, so add it to the other side. And then next, we want to factor this trinomial we created. Well, we just said that it would factor to x plus 4 times x plus 4. And because it's the same thing, we write it once with the square, if you remember from factoring. So x plus 4 squared. Now that equals 20 plus 16, which is 36. Now we still want to solve for x. That's the whole point of this. So we can get rid of the square by doing the inverse operation, which is taking the square root. But what you do to one side, you've got to do to the other side. So the square root and the square cancel each other out. So you have x plus 4 here. That's what's left. And the square root of 36 is plus or minus 6. Now we subtract. Well, you can split it up here if you want to. I subtract the 4 to the other side and get x equals negative 4 plus or minus 6. Okay, and you're going to have 2. So x equals negative 4 plus 6, and x equals negative 4 minus 6. So you've got to split up this plus or minus. That's how you get your two x's. Remember, we're quadratic, so most of the time you have two roots. Not all the time, but sometimes. So x equals over here, x could equal 2. And on this side, x would equal negative 10. So that means on your quadratic, it would cross at 2 and negative 10. So we just solved it by completing the square. Now, if you need to go back and rewatch that, please do, if you didn't get it the first time. That's what the videos are for, to go back and back if you still get stuck. All right, so let's do another example together. So here's one where we have an a greater than 1, 4x squared plus 12x plus 16 equals 0. I'm going to divide that a, so I can get rid of that. And because we also have to divide this side too. So we end up with x squared plus 3x plus 4 equals 0. And that means sometimes you may end up with fractions. So just be prepared for that. Okay, so now you want to move your c to the other side, so we're going to subtract the 4. And we leave a space or a blank or a box. So we can create that perfect square trinomial. So remember, what goes in the box is b divided by 2 squared. So in this case, we're going to end up with a fraction. 3 divided by 2 is 3/2. Squared is 9/4. We add that to both sides. And now we need to factor our perfect square trinomial that we made. So if you're having trouble factoring it, especially when you get to the fractions, I know the other example was easier to do, then really what goes here, I mean, if you noticed it from over there, it's x plus or minus depending on what it needs to be, b divided by 2. Because 3/2, if you add it together, add up to 3. If you multiply them, they're 9/4. Just like in the other example, it's a fraction, so it's a little bit trickier. So if you're having trouble with those fractions, it's just b divided by 2 is what goes here. Now again, these fractions, negative 4 would be negative 16 over 4, and we're adding 9/4. So that ends up being negative 7 over 4 on this side. Okay, so you got to remember how to add up those fractions, same denominator, add or subtract the numerator. All right, now we're still doing the same steps, it's just weirder because there's a fraction, okay, but nothing different. Now we can take the square root of each side, and so over here is just x plus 3 over 2, because the inverse operation of the square root and the square equals the square root of negative 7 over 4. All right, now the square root of negative 7 over 4 is a little weird to do, okay, but we can split it into the square root of negative 7 over the square root of 4. Same thing, all we did was split the square root up. That becomes, we know it would be plus or minus the square root of 7 with an I, because that's how I get rid of that negative, remember, from the complex numbers. So I have an I square root of 7, or you could put the I over here, but it's not supposed to be under this square root. And remember, the square root of 4 is 2. Okay, so this is tricky, I agree. If it was an easier number, you'd be better, just like the first example. Okay, but I wanted to put an example with fractions and imaginary numbers. So now I have x plus 3 over 2 equals plus or minus I square root 7 over 2. And then I subtract, so x equals negative 3 over 2 plus or minus I square root 7 over 2. And because you can't actually split this up and, add it up because we got this imaginary number here, you can just stop right here. Okay, so what this should tell you about your graph is that it doesn't cross, right? I don't know exactly the vertex, you could figure that out, but it doesn't cross. We don't have real x-intercepts, we have imaginary x-intercepts, so you can stop here. And a lot of your answers are going to start looking like this. So if you need to rewatch this again, rewatch how we did the square root of negative 7/4, please do, okay? It's really important that you get this, so over as many times as you need to make sure you understand. Okay, so again, rewatch as many times as you need. Make sure you understand those steps. Moving c to the other side, making a perfect square trinomial. You're going to need to memorize b divided by 2 squared. That's what goes in your box on both sides. And don't forget to do your questions and your summary, okay? What does it mean to complete the square? That's what we did when we had, I don't remember what it was, something like this. Whatever, when we're completing the square, we're putting that b divided by 2 squared in here. So completing the square is making a perfect square trinomial using b divided by 2 squared. Okay, and so that's how we solve. We're solving by making a perfect square trinomial, and then from there factoring and solving for x. So that's what it means to solve by completing the square. That's all for now. Thanks for watching.